Welcome to Study Loop.
This is the answer to Chapter 13, problem number 49 from the Smith Organic Chemistry textbook. And this problem tells us that reaction of t-butyl pentyl ether with HBr forms one bromopentane and compound B. And we're then told that compound B has a molecular ion at 56. And it gives 3 particular peaks in its IR spectrum. And so we're asked to propose a structure for B and draw a stepwise mechanism that accounts for its formation. And so it might be easier to actually just start with the stepwise mechanism and then see if our spectral data makes sense for what we get. But since this chapter is about mass spec and IR, we'll start with the mass spec and the IR and use the mechanism as confirmation. So we have an M to Z of 56. This suggests perhaps 4 carbons for 48, and that would leave us with 8 hydrogens. And so the HDI, assuming that that is the correct formula, the HDI there would be 2 times 4 plus 2 minus 8 is going to be 2 over 2 is going to be 1. So we have a ring, or much more likely a double bond. And so when we look at the IR data, what we see is CsP2 H bonds. So we do probably have a double bond. CsP3 H bonds, which are ubiquitous. That doesn't tell us anything. And then we do see a carbon-carbon double bond at the 1650 wave number. And so given all of that information and given this piece of the molecule here, I'm going to go ahead and say that what we end up with is this. Oops. So we end up with this, or if you prefer, I can write it like this. Okay, and so that's the correct answer, but we are also asked to draw a mechanism here, and so I'm going to do that on this fresh page. And so let's see, 1, 2, 3, 4, 5. So here's our starting material. Okay, and so the first step in this reaction, treatment with hydrobromic acid. This oxygen is going to become protonated. And so it will have a positive charge. And so that is going to open up the way for the bromide ion that we formed in the previous step, which is going to have 4 lone pairs and a negative charge. So this is going to attack this carbon to which the oxygen is bound. Those electrons will revert to that oxygen. So that's going to get us to this 1 bromopentane that we were told is a product. And then also to here. So this tert-butoxide ion. Oh, you know what? It's not going to be a tert-butoxide ion because I forgot that it was protonated there. Okay, so it's actually just going to be t-butanol. So, okay, so this t-butanol can be protonated once again. So there's still some hydrobromic acid floating about. So this oxygen can pick up another proton and become doubly protonated. So when that happens, it's going to have just the one lone pair now and a positive charge on it. And so now it's going to be ready to leave as water. And so that is indeed what will happen. And so that is going to get us to this carbocation. Okay. And so from there, what can happen is, so I'm actually going to change the way that I draw one of these. So I'm actually going to draw the hydrogens on this one, and you'll see why momentarily. So what's going to happen here is that, again, we can call on this bromide ion that we've generated to snatch a proton. And so this is going to form a double bond here. And so that is actually going to get us to our final product B. Okay, and so this is molecule B. And so that's the stepwise mechanism that we were asked to draw. And then again, if we look back at the first page, this is how we got to that same answer using the spectral data. And since these two answers agree, I would say that's a pretty strong indication that they are the correct answer, and indeed they are. And so again, that's how to solve this problem using spectral data. So use the M to Z, the molecular ion that we're given, to figure out a formula, calculate an HDI for that formula, look at the IR data, and see what makes sense and sort of piece it together from there. And then, again, we were asked to draw a stepwise mechanism. So here that is on page 2. Yeah. And so that's the answer to chapter 13, problem number 49.